Good afternoon, Mr. Eddie Fong, Chairman of MPMA PLASTECH MONTH 2021 Organizing Committee and Secretary General of MPMA. Distinguished panel speakers, Dato Ling Kopun, our President of MPMA, speakers and participants, welcome to the 6th webinar in the MPMA PLASTECH MONTH 2021 with the title Sustainable Flexible Packaging Trends 2. To begin with, let me run through the etiquette of rules of the webinar. We have muted and turned off the video for all participants. This is because we are using a conference platform on Zoom, and this feature is activated to ensure no disruption to the speakers during the webinar. Participants may ask or post questions related to the presentations in the chat box during the webinar. The speakers will only answer questions that are clearly written and based on the presentations. Kindly refrain from marketing your goods, services in the chat box. Kindly also refrain from posting comments or remarks to questions posted in the chat box. The chat box is only for queries related to the presentations. The organizer reserves the right to remove participants who run afoul of the webinar etiquette. The PLASTECH MONTH 2021 is brought to you by MPMA with the generous support of sponsors from the Malaysian plastics industry. Please allow me to thank each and every one of them. Our exclusive platinum sponsor, Monitor ERP System. Gold sponsors, BP Pops Jakarta, Milliken Asia Private Limited, NGR Malaysia Sdn Berhad, Petronas Chemicals Group Berhad, Reifenhauser Braun from GmbH, and Windmoller and Houses Asia Pacific Company Limited. Our silver sponsors, Albert Sdn Berhad, Not Mechanica SPA, and Cisco Software Malaysia Sdn Berhad. Bronze sponsors, Autotest Malaysia, Ben Meyer Specialties Malaysia PLT, Boros Private Limited, Husky Injection Molding Systems Malaysia Sdn Berhad, Recommend Malaysia Sdn Berhad, Sigma Soft Sdn Berhad, and Torre Plastics Malaysia Sdn Berhad. We have one other sponsor, which is Krybert TPE Technology Malaysia Sdn Berhad. A big thank you to all our sponsors for making the MPMA PLASTECH MONTH 2021 a reality. In addition to our platinum sponsor, Monitor ERP Systems, for their contribution towards the event, we will now play Monitor ERP Systems corporate video. Thank you, Monitor ERP Systems, and Mr. Daniel Hegmark, who is the Managing Director of Monitor ERP Systems, for your support towards the MPMA PLASTECH MONTH 2021. Ladies and gentlemen, without further ado, let me introduce to you our moderator for today's webinar, Mr. Peiken Cheng. Mr. Peiken Cheng is the Executive Director of THM Plastic Industries Sdn Berhad, and he has been with THM for 13 years. His principal role in THM is overseeing the management of THM's operations. He graduated from the Northwood University in United States, major in international business. Mr. Peiken Cheng is also the Secretary General of MPMA Northern Branch. He holding this position since 2016. Before that, he has been a committee member of the MPMA Northern Branch since 2012. It gives me great pleasure to present our moderator today, Mr. Peiken Cheng.
Hey, hello, everybody. Um, thank you, Chan. And my name is Bacon, and I believe Chan has just made a introductory to myself. And yeah, everybody has been wondering why my name is Bacon. I wanted that too. Well, let's start for today. And for today we have five speakers. One, two, three, four, five speakers. And let us introduce Mr. Lucas. Mr. Lucas, wait, hold on. Let me see.
Good afternoon, Mr. Chung. How are you doing?
I'm doing very well. My computer is not doing well. Give me 1 second.
That's right.
Wait. Okay, Mr. Lucas Miskovsky. He's the technology sales manager for Bob's Asia Pacific, and he manages the regional sales of vacuum metallizing and coating portfolio as well. He's the business development and he involves in business development and marketing for sustainable, flexible packaging across product lines. With his very good experience of 7 years, specializing in food and beverage packaging industries. So before Bob's, he was working for Sadell under Petra Level Group, and he's also a graduate from University College of London with bachelor degree in mechanical engineering. Let's have Mr. Lucas for his presentation.
Thank you very much, Mr. Chung. So I'll be sharing my screen. Just bear with me 1 moment. Screen 2, okay. And okay. So do let me know if my screen does pop up on your screens.
Yes.
That's clear. Okay, so right. Thank you very much for the kind introduction. For all guests joining from Asia, a good afternoon, and a great thanks to MPMA for organizing PLASTECH 2021 virtual conference. It's a warm welcome to my talk on coating and metallizing technologies for sustainability, focusing on packaging applications, and I've already been introduced by Mr. Bacon Chung, so I will not introduce myself again. Thank you very much. I would like to start with acknowledgement to the sustainability pledges. As we know, the linear economy places the future of our finite resources and materials in jeopardy, with many raw materials within 1 to 2 lifetimes running out, because as a collective, as the globe, we have decided to simply throw it away, burning it for energy or burying it in landfills as it is more convenient to do so. Approximately 15% of the wealthiest nations account for approximately 80% of the world's natural resources, sending waste in containers thousands of miles to then be processed in nations where the cost of labor is so cheap that a small profit could be made. When China, the then largest importer of plastics waste, decided to stop accepting it in 2017 due to its lack of value and negative environmental impact, many nations woke up to realize that they had no option but to change. A perfect storm was brewing, and so enter Dame Ellen MacArthur, a retired English sailor who really understood the definition of finite resources. During her 3-month journey circumnavigating the Earth, she compared her grueling sailing expeditions, where she had finite food and water to survive, to the way most business models operate as a whole, as a linear economy, and wanted to make a change. And so she founded the Ellen MacArthur Foundation in 2010. For many years, she campaigned for a circular economy, and it was in 2018 the landmark moment arrived at the World Economic Forum in Switzerland. Companies started to pledge to transition their business models to a circular economy. The momentum kickstarted widespread adoption in the plastics industry. Social media from disgruntled netizens the world over posted their displeasure of the linear economy and its impact on the environment, which resulted in even faster adoption of circular economy. Within the packaging industry, retailers, brand owners, resin suppliers, converters, filmmakers, and machine suppliers have pledged in unison to follow the 3 R's of reusable, recyclable, and reduction, or compostable, transforming packaging structures to become monomaterial, with a target to still maintain the performance of previous mixed material structures. The timeline and targets may vary depending on which company you speak of, but back in Q1 or Q2 2018, many have decided to meet this commitment within 2025 or earlier. Today, Ellen MacArthur Foundation has received 500 plus signatures committing to sustainability, and it continues to grow. In the last 4 years, BOPST has had various collaborations and partnerships to assist with the development of monomaterial structures, with the aim of improving the value proposition of plastics for the packaging industry. Let's together take a look at the direction that BOPST has taken and the solutions we have formulated with our partners in supporting the industry push for sustainability. BOPST has been focusing all its efforts on flexible packaging solutions, targeting 3 pillars of sustainable flexible packaging. The first and most sought after solution in the market today is looking at monomaterial polyolefins. The idea is to replace mixed materials, normally PT with PE, with either PP to PP or PE to PE laminates. In Europe, CFlex, a well-recognized consortium of 160 plus companies, associations, and organizations representing the full value chain of flexible packaging, together has provided the industry with resources and guidelines to support sustainability. CFlex has published guidelines for sustainable packaging back in July 2020, which states monomaterials has to account for more than 90% of the total packaging weight, where coating, inks, adhesives must account for less than 5%, since the vast majority of nations has infrastructure capabilities for mechanical recycling. The first consideration is for monomaterials to be compatible with mechanical recycling. The second pillar of sustainable packaging is bio-based, from which natural renewable resources are the natural resource. This is a more niche area, but it is growing in consideration, where currently only 1% of plastics are considered bio-based, compostable, or biodegradable. Today, materials such as PLA, PHA, PHB, and PHV, or cellophane, is considered in packaging designs. A majority of these plastics are made from sugar from plants. If the product is made to be 100% compostable, it may be suitable for home composting under certain conditions with no danger to the environment. In contrary, however, biodegradable plastic is a little more difficult to find, as some can be oxo-biodegradable, meaning that a plastic made from petroleum with additives that, when exposed to accelerating factors such as sunlight, will break down into tiny microplastics, polluting the environment. Australia, for example, banned biodegradable plastic for this reason, whereas they have accepted 100% compostable materials such as PLA. This brings me to the third pillar of sustainability, which is paper or fiber-based. Many ask why paper packaging is considered a solution. It is probably because of the compatibility of paper packaging with existing paper recycling streams. In food packaging, where BOPST is heavily involved, we have seen high growth rates of interest and orders of machinery serving this path in food packaging. At BOPST, we have observed near daily press releases over the past 2 years of new product lines replacing plastic packaging. However, the challenge with paper remains firstly with what type of paper should be used, how it needs to be prepared for conversion, and of course, the type of barrier and flexibility of paper that can be achieved whilst trying to retain a high percentage weight of paper content within the packaging. I will now touch upon monomaterial and paper-based solutions, as this accounts for 98 to 99% of all global food packaging today. This brings me nicely to a point on what are the mega trends for barrier targets. There are many depending on the different food segments, but we find for high barrier application, there are two targets. The first high barrier target is metallized polyester replacement at less than 1 cc per meter squared per day for oxygen, less than 1 gram per meter squared per day for water. The second is ultra high barrier target, where also it's considered as aluminum foil replacement, which is operating at 0.1 cc meters squared per day and 0.1 gram per meter squared per day. Let's take a look at the solutions BOPS and their partners in collaboration has got on with regards to these two mega trends. Here we are presented with the dilemma visually of the mixed material structure, PET to PE laminate on the left, and the right, the intermediate step of developing monomaterial PE. On the left, PET is coated with aluminium oxide or ALOX, a brittle ceramic transparent layer, which is processed on a vacuum metallizer. A barrier top coat is carefully prepared or applied on a coating machine with properties of protecting the barrier layer. Ink is reverse printed, typically with either CI Flexo or Gravure printing machines, and the PE sealant typically undergoes dry lamination, where the adhesive is either solvent or water-based. Even though PET is chemically a fantastic material, which offers exceptional barrier properties against oxygen, and on its own as PET bottles and jars is actually a preferred material for recycling due to its lower carbon footprint compared with glass or aluminium, in a flexible packaging structure, it does not lend itself to mechanical recycling due to its need to be sealed with LDPE. PET, generally speaking, as a sealing layer, has poor sealing performance characteristics, although there is ongoing research on PET to improve sealability, but it is not widely commercial today. On the right is a partially compliant monomaterial PE duplex structure, which is a like-for-like replacement for the structure on the left. The reason why MDO-PE was considered instead of PET was firstly to mimic the mechanical properties of PET. The machine direction orientation process improves tensile strength, stiffness, and optical properties. An EVOH skin layer of a few microns, which is co-extruded, offers good receptiveness for metallization. PET fundamentally has a high surface polarity, which in turn means it has good receptiveness for metallization coating of either aluminium or aluminium oxide. As PE inherently is non-polar, EVOH with high surface polarity is adapted as the interfacial layer. Furthermore, EVOH is one of the best polymeric oxygen barriers available in packaging, but it is water soluble, and therefore ALOX, or Alubond in our case, protects the EVOH as it offers good water barrier. If we look below the structures, there are some data on the total laminate structure by thickness and weight. We wanted to show the percentage of weight of non-monomaterials versus the total structure. The structure on the left, as we have already established, is non-compliant due to its mixed material nature. The structure on the right is partially compliant with the C-Flex designed for the circular economy guidelines, as a percentage of non-material PE is within the ballpark figures that is either compliant or non-compliant. Of course, one can design for compliance to changing the layer density, for instance, increasing the PE sealant thickness. BOPS, from a monomaterial standpoint, focused on PE, firstly because of its maturity of the market, and furthermore, we wanted to create a solution that enabled those who had blown lines. I'm pleased to introduce the one barrier, high barrier solution from BOPS, which is the next stage of monomaterial PE structure development. The aim of BOPS one barrier is to incorporate our know-how in wet dispersion coating of a primer with MDO-PE to obtain an EVOH-free scenario. BOPS underwent 3 phases of development: a study phase of various commercially available primer chemistries, a lab phase testing the 5 best primers, checking for wettability and barrier levels, and a third industrial trial phase where 29 trials were conducted with 16 reels produced. The structure to the left is a transparent solution with alox to the right, and to the right is an opaque solution with Bob's patented Alibond high adhesion, higher barrier metallizing technology. Both structures follow the same steps of conversion. Bob's role begins following the MDOPE production. Then the one-dap barrier primer is applied through the Bob's Vision D850 coating laminating machine. Alox or Alibond is then coated on an Expert K5 vacuum metallizer and laminated on our Nova SX550 with a solventless adhesive, as this would have low thermal impact to PE. The film is then surface printed. Here, the key point when comparing with the previous slide, the previous intermediate solution with MDOPE with the co-extruded EVOH, is that we can reduce the non-material weight by omitting both EVOH and top coat for Alox layers. The data below the structures once again shows an improvement in terms of compliance with CFlex D4ACE guidelines of below 10% for non-material weight. Let's swiftly move on to the barrier performance on the next slide of this one barrier solution. Bob's partnered with Dow for their extensive know-how and resources on PE resins and Hoscal Alpine for their expertise on blown MDO lines. The MDOPE was a 5-layer collapsed structure. As you can see, the barrier performance show is within the normal range for blown PE, but there has been improvements, of course, for priming, for metallization, and so on and so forth. Bob's has tried 3, 5, 7 layers, and in Southeast Asia, the trend is moving towards 5 and 7 layers plus MDO capability. The one barrier primer provides exceptional oxygen barrier properties. When we combine this with our Alox Generation 2 process, we further improve the oxygen and water barrier level. And when viewing the complete laminate with a selected barrier adhesive, we are able to provide a solution that enters the domain of metallized polyester film replacement with a laminate bond strength that passes the marker requirement of 2 to 3 newtons per 15 millimeters. We were able to achieve similar barrier results with Alibond as well. This was an important result for us and our partners, as in the last 4 years, we have had a number of collaborations with brand owners, since they are not able to find these solutions readily available in the market. We firmly believe one barrier will become an important reference in the market for monomaterial packaging, as it ticks all the boxes in terms of high barrier performing sustainable packaging in an economical way. Bob's has mentioned as one of its 3 pillars is to identify barrier paper solutions that is compatible with paper recycling streams. We collaborated with AR Metallizing for pre and post metallization lacquers and paper, and Michelman for their pre and post metallization barrier and heat seal lacquers. Bob's provided our process know-how for metallizing with Alibond hybrid coating technology with the vacuum metallizer. This is a mono web structure and provides the foundations for a number of newly available barrier paper products in the market. As you can see, there's one example from Nestle with the Yes Bar, which was launched in 2019. As you can see, the base paper exhibited initially no barrier properties, but once coated and metallized, we were able to achieve the target of metallized polyester replacement. And this was an important milestone, which was first achieved back in 2019. The Bob's One Barrier solution incorporates the hardware, process know-how, and collaborative efforts with like-minded partners who are aiming like Bob's for a circular economy with sustainable packaging. On the left is the Vision D850 coating laminating machine, which is used for applying the primer and of course can be used for lamination, where we leverage our know-how of inline corona treaters to improve the surface energy of the film, a gravure coating station, which can work in both forward and reverse for uniform and flawless coating. Our drying technology is second to none, as we utilize hybrid drying technology with double-sided airflow for fast evaporation, which is favorable to counter the tendency for PE to extend under heat load conditions. BOPS is also well known in the market cross-platform in handling web tension capabilities, which is crucial when handling PE. On the right is the Expert K5 vacuum metallizer. We utilize a number of unique functionalities such as a 700mm drum, high rate source, and an optimized plasma pre-treated design in combination with our state-of-the-art ALOX or Alubond processes.
Excuse me, Lucas. Lucas, you have 3 more minutes.
Thank you very much, Mr. Chan. We'll be done soon. Thank you. And BOPS the BOPS K5 metallizer is really designed with sustainability in mind and is the go-to for most heat-sensitive products such as PE. BOPS strongly believes in an integrated package solution where quality can be assured by a dedicated partner in conversion. Finally, I would like to end my presentation with an invitation to you all. We announced in September that BOPS and our project partners shall release a follow-up to the Hero first generation samples, which were released in the K Show 2019, with the launch of the Generation 2.0 for high barrier flexible packaging. These samples shall include new ultra and high barrier full polypropylene laminated pouches printed in gravure and recyclable with the option of Alubond, metallized or ALOX layers with solvent-free barrier adhesive and or top coat. It also include the first ever UV Flexo combined with digital inkjet printing for Alubond metallization, full PP laminated bags, barrier performances, using solventless adhesive again for monomaterial pouch design for recycling, and many other structures. Hero 2.0 is done in collaboration with our team of key industry like-minded partners along the entire workflow, which include Dow, Bruckner, Hosokawa Alpine, Elba, Sun Chemicals, Mickelman, Indopoly, and Uflex. And I would just like to say thank you for joining me today. I hope my talk was insightful. And if you have questions or further inquiries, feel free to reach out to my private mail, or I'll be happy to answer them during the Q&A. Thank you very much.
Thank you, Lucas. It's indeed a very interesting topic that you just shared. And dear all participants, if you are interested in the invitation that Mr. Lucas has just invited, please feel free to contact Mr. Lucas.
Thank you very much.
And, here we welcome our next speaker, Ms. Daniel Lee. Ms. Daniel, a Dow Asia Pacific's application development leader. She has more than 15 years of experience in the technical field and collaborates with regional customers to develop and improve their flexible packaging in application such as industrial, food, and hygiene. Ms. Daniel, and company with Jason Yu, but Ms. Daniel will be giving the presentation. Let me introduce a little bit of Mr. Jason Yu. Mr. Jason Yu has been with Dow for more than 6 years in the packaging and specialty plastic business. He has developed a keen understanding of flexible packaging industry and market dynamics in Southeast Asia. His primary focus is in the development of food packaging technology and to accelerate the shift towards a more sustainable packaging ecosystem. Let us welcome Ms. Daniel Lee.
Okay, I hope you can see my slide. Thank you, Bacon, for the introduction. Good day, everyone. Firstly, let me say thank you to MPMA for inviting Dow to present in this virtual conference, Staying Relevant, the Power of Technology on Sustainable Flexible Packaging Trends 2. I am Daniel, and with me, Mr. Jason Yu, Marketing Development Manager, joining me to address your questions at the end of the session. So without any delay, let's dive into today's session on closing the loop with innovation in flexible packaging. Although Dow is a supplier of polyethylene resin, we do not shy away from our responsibilities, and in fact, Dow is very committed to eliminate plastic waste from the natural environment. Through our best-in-class material science knowledge, as well as application development expertise, we hope to forge impactful partnerships with converters, non-government organizations, recyclers, and even brand owners, so as to provide a circular solution to prevent plastic waste from going into the environment. However, before this can be achieved, a radical change in the design of the flexible packaging used today has to be undertaken. This change is actually critical, and it is to make current incumbent solutions suitable for recycling to achieve the circular economy. So what are the key mega trends for flexible packaging? Listed here are what converters and consumers' expectation. Today, consumers are better informed, and sustainable solutions like recyclable packages, less carbon dioxide emissions are in the scope. We also cannot ignore the need for reliability of flexible packaging, as it can improve shelf life as well as reduce food wastage. From the converter side, their wish list is always increase productivity while lowering energy use. Last but not least is definitely customer convenience, so as to meet their expectations. So tender frame polyethylene is relatively new to the market. So let me elaborate a little bit more about the technology. It's actually made with a tender frame biaxial oriented process, similar to a BOPP line. In the process, polyethylene is firstly extruded from a cast flat die. Then it is stretched in machine direction by about 4 to 5 times, followed by about 8 to 9 times stretching in the transverse direction. Conventional PE resins are difficult to stretch under the conditions due to narrow stretching window. Dow has developed and launched a new resin called Innate TF80, which has superior processability on industrial scale tender frame line. After the high level orientation, PE films get outstanding physical properties and narrow gauge variation, which is ideal for printing substrate or toughness enhancer layer for all PE structure. The right top chart shows the TFBOPE, demonstrates a good balance of stiffness and toughness, while able to provide clarity that brand owners and consumer loves. BOPE can also provide high clarity, but due to the incompatibility of PP and PE recycle stream, it does not score well on the recyclability part, but still better than BOPET or BOPA. The bottom right chart shows the comparison of existing technologies in the marketplace today against TFBOPE. TFBOPE demonstrates a best balance of toughness and stiffness while providing best in class in transparency and glossiness. So the first packaging format we are going to look at is the polyethylene stand-up pouch. Here is a case of TFBOPE-based stand-up pouch development. TFBOPE replaces BOPA, providing functionalities such as printing web, toughness enhancement, and etc. TFBOPE laminated solution demonstrates outstanding performance such as pinhole resistance, impact and puncture resistance, make it fits well for dry products and liquid SUP. One key thing to take note is that the barrier performance will not be as good as those using BOPA or BOPET due to the reduction in oxygen barrier performance. Dow thus offers unique solution to improve moisture barrier via the use of Elite 80 6900 enhanced polyethylene resin. So do reach out to us for more information. Although applications with oxygen barrier performance is not ideal, applications which does not require high barrier performance can still be used, such as dry laundry detergent, pet food, rice packaging, and also dry food items. So let's continue from the previous slide. Here, let's look at the drop test of the pouches, TFBOPE laminated solution, and the MDO laminated solution. The MDO-based pouches able to survive 0.5 meter of drop height at 50% of survival rate, while the TFBOPE based pouches has 100% survivable rate in cumulative of 6 site drop tests. When we increase the height to 2 meter, MDO-based pouches unable to survive the drop test, whereas the TFBOPE-based pouches can still pass. This clearly demonstrates the difference performance when the same PE lamination film was laminated to MDO or TFBOPE film replacement substrates, demonstrating the unique performance of TFBOPE films. So with Dow's portfolio of linear low density resins from our Dowlex, Elite, Elite 80, Affinity franchise, Dow will have the right resin to create a suitable PE lamination film designed to laminate to TFBOPE as the print replacement substrate to suit your end user's needs. In the previous sharing, the lack of barrier performance limits the use of all PE SUPs. What if I have a need for improved barrier performance, in particular oxygen or moisture barrier? Thus, let's look at Dow's solution towards the recyclable barrier stand-up pouch. We all know that polyethylene film has fairly good moisture barrier, but not for oxygen barrier. In this slide, it demonstrates to you an option of using TFBOPE as print substrate and laminate it with co-extruded EVOH PE coupled with retain. Retain is a polymer modifier, enables the recycling of barrier polymers like polyamide and EVO, which was once impossible. Now, this recyclable barrier SUP able to meet the required barrier performance and is applicable to dry food, snack food, and facial masks of type of packaging while remain recyclable. The right chart shows the comparison between BOPA laminated to a PE lamination film against Dow's recyclable barrier SUP film solution. Dow's unique solution allows excellent oxygen barrier while maintaining pouch stiffness and toughness. In the next slide, let us talk about retain and how it works. Retain was designed as a compatibilizer of polyamide and or EVO with PE. Without compatibilizer, polyamide or EVO does not disperse into PE, hence forming big opaque particles. So retain functions by reacting and forming tiny droplets in the PE matrix as shown in the picture on the right. The left chart shows the film performance comparison of EVO PE as recycled stream adding into a middle layer of PE film with and without retained resins. After adding retain, optical and mechanical properties were significantly improved, even comparable to a PE with 100% virgin resins. This results clearly demonstrates the value of retain and coupled with Dow's portfolio of high pressure copolymers and as well as linear low density polyethylene. Dow will definitely have the right solution to meet your end users' needs. Thus, do connect with us to find out more. The next packaging format we are going to look at is the all PE thermoforming films. A typical incumbent thermoforming films solution for packaging applications uses polyamide for thermoformability, which is related to stiffness and toughness with the added advantage of shape retention, after forming can be achieved. And with polyamide, the draw depth can also be deeper during the thermoforming process. However, as explained earlier, polyamide may not be the best material of choice when it comes to recyclability of such articles. Although Dow has retained the polymer modifier to recycle such articles, the most straightforward way is to design monomaterial structures for easy collection and also send for recycling. Thus, we hereby introduce to you Dow's solution for all PE thermoforming films, as seen on the bottom left. This solution allows one to achieve a draw depth of 5 centimeters while maintaining excellent formability and balance of toughness and shape retention. The image on the right demonstrates the edge and shape stability after thermoforming, resulting in excellent appearance to the end users. The low temperature dart impact and puncture resistance charts at negative 20 and negative 40 clearly shows that all PE-based film demonstrates better performance than the PA-PE co-extruded base film. Such all PE-based film is targeted for low to no oxygen barrier requirement, low and room temperature condition, such as frozen food and medical device packaging respectively. So depending on the demand in performance from brand owners or end users, Dow has a wide selection of polyethylene resins for different fabrication processes, as well as providing tailored solution to meet packaging expectations. So the next packaging format we are going to look at is the all PE pillow pouch. So a typical pillow pouches uses BOPP, BOPA or PET as print substrate and laminated to a PE lamination film. Here we use TF BOPE to replace BOPA and laminated to a 80 microns PE lamination film for vertical form and seal pouches to enable the concept of recyclable pillow pouches. The right chart showing the TF BOPE laminates can deliver similar toughness, shelf appearance, and packaging efficiency. The only performance vector lower than BOPA-based laminates is the ultimate tensile stress in the machine direction. Okay. This will not significantly impact the performance of the pouch, and in fact, the tensile strain of TF BOPE-based laminates are much lower than BOPA laminates, which helps to prevent undesirable elongation issues, which may result in delamination and other related problems. Such structure is applicable to detergent powder, frozen food, and also dry food packaging. So the last packaging format which we will cover is a very new innovation from Dow, Lab Seal Stick Pack, targeting at material savings and performance approach. Lab Seal Stick Pack, when compared to traditional sachets or thin seal articles, demonstrate a unique proposition in which typically we can save material in the range of 10% to fabricate a small package with the same amount of content. With the use of TF BOPE, recyclable Lab Seal Stick Pack is now a reality. By using TF BOPE as print replacement substrate to replace BOPET for traditional structures, there is no significant difference in terms of tear resistance, as well as stiffness, which affects the feel of the stick pack, as shown on the bar chart on the right. Further evaluation of TF BOPE-based Lab Seal stick packs can still provide the easy tear demand from end user while maintaining pack reliability and integrity. The TF BOPE-based Lab Seal stick pack can easily survive the fish tank evaluation, which checks for leaks and packaging integrity, with the added advantage of productivity, where production evaluation allows the production of up to 50 packs per minute per lane. One of the key performance to evaluate for lab seal stick pack is also the seal strength of the sealant to sealant, and is in the graph is expressed as the light and dark gray curve, as well as the seal strength of the sealant to the other surface of the print replacement substrate, which is expressed as the red and blue curve, under different sealing time with the same sealing pressure applied. From the evaluation, it is expected that sealant to sealant seal strength will be good, and with Dow's unique solution in polyethylene resins used in the sealant layer, we can achieve a good heat seal initiation temperature. Even when we are sealing the sealant layer to the TF-BOPE film, which is the red and blue curve, we can again see that decent seal strength of up to 30 Newton per inch can be achieved. This is the key performance that keep the lab seal in place for stick pack. The Dow's unique offering in polyethylene resins as well as high pressure copolymers products can assist you to migrate from traditional structures for lab seal stick pack to recyclable solutions. Dow has spent enormous resources to develop packages that are designed for recyclability. This is the first step and the most critical step to achieve a circular economy. Dow, as a responsible polyethylene resin producer, want to use innovation to divert plastic waste from the environment and hopes to work with all in the value chain to create a sustainable future with flexible packaging. Thus, together we can close the loop and seek the solution together to achieve better outcomes for Mother Nature. Thank you, and I hope you enjoyed the presentation. Again, I wish to express my thank you to MPMA for inviting Dow to present in this virtual conference, and it's a very wonderful experience. Thank you.
Thank you, Daniel. It's indeed a very fruitful and informative presentation that you have just presented. And I myself, I'm a Dow material user as well. So I can tell that Dow is actually giving many ways of solutions for packaging wise in terms of like sealing and also tensile and all that. Thank you, Daniel. And I believe that there are converters and brand owners are participating in this conference as well. And that certainly has gave us enough input in bag forming and saving materials and all that, right? So if anyone that has any questions, please raise it in the chat room so that we can present this to Ms. Daniel after the event. Next, we would like to introduce, and for the third one, the sustainable packaging based on oriented PE films. We welcome Mr. Marcel Buddha. Is the regional technical sales manager for Wim Moller and Hocha, W&H. He graduated with Master of Science Mechanical Engineering and Business Administration, specializing in plastic processing. And he studied plastic processing for more than half a decade. And yes, with his passion and knowledge, Marcel helped many of the W&H customers to find the right blown film equipment for their products. So whoever that you are using W&H, please pay enough attention. Mr. Marcel, please.
Thank you, Bacon, for this kind introduction.
You're welcome.
Let me share my screen and maybe just give me a short feedback if you can see this presentation.
Yes, perfect.
Thank you.
We can see it.
So also from my side, a good afternoon and a warm welcome to all of our participants in the name of Windmüller & Hölscher. So, and a big thank you again for MPMA for hosting us here today. So we have heard some very interesting information about monomaterial from Lucas and Bobst already, and I would like to present the extrusion solution of producing such sustainable packaging based on oriented PE films. So sustainable packaging, what trends are we currently talking about? So for many years, down gauging, I think, was one of the main drivers in film development. However, the current megatrend and most discussed topic with all of my customers is recycling and how to efficiently process recycled materials on extrusion lines. So, and in this area, we talk about recycling of conventional PE, recycling of barrier films by adding compatibilizers, and of course, moving to monomaterial solutions by replacing multi-layer laminates. So by these monomaterials such as PE. So why is this the biggest megatrend we see since a couple of years? Actually, every single day we hear and read about the bad image of plastic and plastic packaging materials, and the topic is discussed mostly on a pure emotional level, seeing the plastic soup and turtles eating plastic waste in the oceans. So many brand owners, they committed themselves to pack their products in reusable or recyclable packaging. And in many cases, the year 2025 is mentioned in combination with this promise. So only changing the packaging from non-recyclable to recyclable, it will not solve our problems with littering and the plastic soup we see here. But on the other hand, making packaging recyclable will give at least the opportunity to change the mindset of plastic materials from a single-use resource to a material with a certain value, which must be recovered. So in the end, we all here, we are specialists, and we know that plastic in many cases is the most resource-saving material to pack products in. So, and one example of this very resource-saving packaging type is, in the end, a standard pouch. Yeah, if we compare the amount of goods that can be packed with 1 kilogram packaging, the standard pouch is still unrevealed, and in the end, it can pack up to 56 kilogram of soup, for example. So this means more than 6 times soup compared to a can, and almost 33 times more product compared to a glass jar. If we look at growth and urbanization, and this leads to new challenges as well. Yeah, transport volumes, distances have been rising since years. Yeah, and knowing this fact, as experienced specialist, there are many studies out there showing how much more CO2 would be raised if you need 33 times more trucks to bring the same amount of soup to the supermarkets if you use glass. And in addition, you need up to 26 times the trucks to bring empty glasses to the filler. So I think the responsibility of the whole industry is to combine the potential of plastic packaging with the recycling goals of the OEMs. And one case study how to do this is our standard pouch, which we developed for K 2019 in the beginning, but improved it since then many times and added functionalities. So we have heard already today that PET and PE are too different to each other to be recyclable together. For example, melt temperatures do not fit. And however, in order to find a PET replacement film based on PE, we have to have a close look at the end application and the process steps to produce such a pouch. So these steps are extrusion, printing, yeah, 2 fields of expertise where WH feels very comfortable in by supplying the machines, but also lamination, pouch making, converting, and handling of the packed goods is very important. And here we have partners in our team to make this not only a film, but make this a full product. The pouch that you see here in this picture is the collaboration of WH and these partners, and it is completely polyethylene based, and it consists of 2 films, a 25 micrometer stretched MDO PE film and a 110 micrometer sealing film. MDO, we have heard that today, stands for machine direction orientation. That means we stretch the film a lot heavily, 5 times, 6 times in machine directions, altering the film properties in the meantime. The MDO PE film is the film, the 25 micrometer film is the film that replaces PET in this pouch laminate. And this is the one that we spend so much time and effort developing. So why do we stretch it? It needs to be very clear because this film needs to be back printed. Okay. It also needs to be heat resistant because it is the outer layer and it gets in contact with the sealing bars. The film needs to be extraordinarily stiff and flat in order to be printed at high speeds on flexo or rotogravure printing presses. And the stiffness is needed to make sure it is a stand-up pouch and stands and protects the good inside. So our goal was to develop a film that runs on existing downstream equipment. And the experience we gathered during this project was, so far, it works. Both films that make up the pouch were extruded on the same Varix 2 blown film extrusion equipment we have in our lab. Yeah, the 110 micrometer film is a 5-layer sealing film. It could also be a 3-layer and is a standard blown film without any orientation. And as mentioned, the stretched MDO PE film, there we need all these enhanced properties, yeah, clarity, stiffness, heat resistance. So let's have a look a little bit on the MDO technology itself. So here you see a possible layout example. And what is the goal for every film extrusion company? I guess it is excellent, consistent film quality in the end, combined with the great efficiency of the machine. So great efficiency usually means a high output on such a blown film line. So we achieved this with our Varix 2 lines by adding different leading technologies. For example, the machine speed to 300 meter per minute. That means the machine speed will never limit the output. And of course, to make this product work, we try to bring in the best available MDO machine technology in the market. If we look at the basic layout, what is very important for this process in difference to standard blown film extrusion, okay, standard is still, we have an air ring, we have an gauge control system, we have one profile measurement system, then we go to the Hall off, and there we have an MDO stretching unit here, and we have a secondary thickness measurement after the MDO. Why this is so important, I will tell that in detail a little bit later. So our MDO-M, as we call it, is very modular and tailor-made to your needs in the end. It can be 8 rollers, 10 rollers, plus 2 additional preheating rollers are available. So in the end, we look up to 12 rollers. Each roller is temperature controlled up to 160 degrees to make sure that also high density material can be nicely heated up and stretched. The stretching gap itself, it is adjustable to your needs, to the product needs. Of course, these lines, these Varix 2 lines are not only for MDO products. It's possible to bypass the MDO and just produce the sealing film or any other standard blown film on this type of machine. And we have our patented OptiFill P MDO automation for 2 reasons. One is to massively reduce the trim, and secondly, to give you the best planarity of MDO film in the market. I would like to show you a small video from our lab to give you a more moved imagination of how the MDO can look like. This is our lab, and we will follow the material through the extruders shortly. Okay, in the video you have seen the OptiFill PMDO automation and how it works, and I would like to present this system in detail a little more. So it ensures that you produce perfect film while minimizing the amount of process waste during production. So let's take a look at the stretching process from a film's perspective. So at first you come in with a nice and flat profile, okay? So this is how you normally extrude. And when you stretch this film, it gets thinner and narrower at the same time, just like a rubber band that you would stretch. Yeah, you can also see this in the secondary film profile after stretching. Yeah, the picture on the bottom right. You can wind this film, or at least you can try, but the edge buildup would cause defects in the film, making it impossible to process downstream. Here, you would have to cut away a lot of film in the edges, creating a lot of plastic waste and losing machine productivity. So how can we combat this phenomenon? So here is where PMDO comes into place. And now you see the film profiles with MDO automation on. We alter the primary film profile with the heating cartridges and bearing in a way that counteracts the edge buildup after stretching. What I mean by that, we create two thin spots in the bubble exactly where the film edges will be in the MDO process. And of course, we have a reversing haul off. That means the two thin spots needs to travel with the reversing of the haul off. So the film entering the MDO unit is not a perfectly flat film like in the slide before. It's a warped film with thin edges. The stretching process smoothes out the film so that you achieve a great profile with much smaller amounts of film that you have to cut away. The edge buildup cannot be eliminated completely. This is physics, but you can reduce the amount that needs to be cut away by about 50%. The know-how around PMDO automation grows more and more with every machine that we have in the field and every customer trial that we run in the lab. The technology has been around now for more than 8 years, and we are continually improving the algorithm behind it. And of course, to close the loop, as mentioned before, this edge trim, which is unavoidable, can be regrinded and then used in the sealing film. And then the standard pouch is fully made of monomaterial, and we can recycle it again and use this regranulate as post-consumer recycled material for products like shopping bags, waste bags, or collation shrink film, which we have done so far. As presented to you before, we developed and fully tested this PE MDO film for the K-Show 2019. And after that, we sent approximately 250 sample reels of this film to converters across the world, and we received very positive feedback on the performance of this film. So due to COVID-19, testing in our facilities in Langerich is a little bit challenging at the moment, but still we are doing remote trials and tests together with many customers in our lab, and we are happy to invite anybody of you who is interested in testing such films, maybe with your resins, with your recipes, to Langerich and have such a trial. Till now, we performed together with our customers more than 1,500 hours of trial time on our MDO lines in this lab. This is about 60% of the total available MDO testing capacity in our lab. Some of you may have been present in one of these test sessions and have accompanied this test. And what have we tested in addition to this use case that we have shown you, this standard pouch? We have tested stretching barrier raw materials like polyamide nylon, EVOH. We have used different sealing and heat resistant layers. We have produced films in blocked and non-blocked structure, 1-up, 2-up, and saw challenges and solutions for both methods. We are also experienced in adding co-extruded barrier materials like EVOH to get OTR, WTR values, different sealing and heat-resistant materials in these blocked and unblocked structures, and using the recycled materials. And we have even gathered experience in barrier coatings on anorganic basis. So, and most important, when you have such a line, you need service and you need to be trained, because this is a kind of a new process added to the standard blown film. And for that reason, We have hundreds of service technicians at WNH, but 15 dedicated service technicians that are trained as MDO experts for installation of training of these more complicated process, and we will help our customers to make this product work. So if we look at the number and positions of MDO units, we have a nice more than 100 units installed all over the world, evenly spread on the whole world, and the numbers are rising and rising because it is the big mega trend as mentioned before. What are the next steps and the big trends we see after this development? We have heard it a lot from Bobst about the typical demands of oxygen barrier and water vapor barrier. So in our different testings, we have reached OTR values of below 1 with EVOH co-extruded film with a very low EVOH content inside, because let's assume when you are adding 10 micrometer EVOH in such a film and stretch it 5 times, 2 micrometer are still in the stretched film, and this is very much compliant with the CFlex guidelines. Yeah? So these are the next steps. Bring in the oxygen barrier to products into the supermarket. The basis is there. We have done many tests, and the products will shortly arrive, I guess, in the supermarkets all around the world. A short summary. So sustainability is changing the packaging market, and with new demands and new solutions. New solutions need new technologies, especially in the extrusion area, but maybe as well, even if we see it works from the backmating, etc., maybe across the whole process chain, all companies need to be ready to adopt technologies. And the installed base of extrusion machinery will either need to be replaced or retrofitted with MDO units to fulfill this OEM goals of fully recyclable film by 2025. And there are many products out there that still need to have oxygen barrier. That means either co-extruded EVOH or adding coatings are necessary. Thank you very much for your kind attention, and I'm happy to answer all of your questions in the Q&A session. If you have questions after today's webinar, please feel free to contact me or your local sales representative of WNH in Malaysia. Thank you very much.
Thank you, Mr. Marcel Buda. Yeah, so to all the participants, if you have any questions or any inquiries, please send it to Mr. Marcel's email, or you can get in touch with the Secretariat to get Mr. Marcel's contact, right, Mr. Marcel?
Yes, of course, Bacon, that's right.
All right, so let's recap for today's topic, a sustainable, flexible packaging trends. Speaking of the environmental issues, and based on the title today, we have well-known machine makers and raw material producers here today to share their roadmap to align with the current environmental issues and solutions to provide a more efficient way to package the products. I believe with our 3 well-experienced presenters' presentations, we are getting a better idea of the sustainable, flexible packaging trend. And yes, let's look forward for another 2 interesting presentations. Let's welcome Mr. Troy to speak a bit on the exploring innovative solutions with ExxonMobil's performance polymers. Let me introduce a little bit of Mr. Troy Moe. Mr. Troy, did I just pronounce it correctly? I'm sorry.
That's correct, yeah.
All right, Mr. Troy Moe is a senior staff engineer for ExxonMobil Chemical Asia Pacific since 2001. Before this, Troy was with Titan Malaysia Sdn Bhd, JG Summit Petrochemical, ICI Australia Education. Mr. Moe holds a science degree in industry chemistry from UNSW, Sydney, New South Wales, and a master degree in polymer science from UNSW, Sydney. Please, Mr. Troy.
Thank you very much. Let me share my screen if I may. Okay, hopefully everybody can see that. Let's see.
Right.
Oh, good, yeah.
Yeah,
Okay.
all good.
Thank you very much. Well, firstly, I'd like to thank MPMA PLASTECH for holding this conference. It's been very, very informative, and I'm sure not only the speakers have got something out of it, but also the audience. I'd also like to thank the speakers that have just spoken before me, who gave some very good presentations. So today, what I'm going to be talking about is perhaps a little bit of a different slant to the previous speakers. I'm going to be talking about innovative solutions from using ExxonMobil performance polymers. Before I jump into the very short agenda, which is actually quite heavily filled, I wanted to explain to you that ExxonMobil obviously is a very large producer of polyethylene products around the world. We make not only conventional polyethylenes, but we also make a lot of performance polyethylenes, which people regard with metallocene type technologies. And what I'm going to talk about today are two new types of resins. One is the Exceed XP8346, and another one is the XP7 series. And I'm going to be talking a lot more about industrial applications today, which is probably a little bit different to the previous talkers who focus more on the primary packaging aspects. I will, however, talk a little about some primary packaging in the talk. And the message that I really want to get across to everybody here is that industrial packaging is an incredibly important part of the polyethylene business. And the more people consider the use of performance polymers, that is the high performing polymers, the cheaper and less use of that particular film that they have to use in their applications, which is ultimately what's going to also help us with our sustainability quest, apart from the recycling and reuse. Okay, so let's go straight into the presentation. Exceed XP8346, bit of a mouthful. I'm going to focus you on the bottom right-hand corner firstly, to let you know that the melt index of this product is 3.5, the density is 916, and I think most people in the polyethylene industry would recognize that this would be a great grade for cast extrusion. And in fact, we focus this grade largely on the cast stretch film market, which is a very important market, okay? And I'm going to talk initially about some of the processing attributes of this polymer. And I have two graphs here to show you that, firstly, compared to, shall we say, a conventional C6 metallocene resin of similar melt index and density, it shear thins a lot more in the extrusion shear rate region. So that means that you're going to have easier extrusion. And it's particularly useful for customers that have wide dies, because the resin therefore is allowed to flow more evenly and better into the sides of the die. Also, the melt strength is a little bit better. And now melt strength is something that we normally associated with blown film, but in cast film, it's also very important, because what it does is it stabilizes the web. And it means that if you can stabilize the web, you normally get less thickness variation. Of course, it's very important to have as good a gauge control as possible, and to make sure that you have less thickness right across the web, particularly on the wide dies. Now, in addition to those attributes, it actually processes very well in the extruder. So you can see here that, compared to this conventional C6 metallocene, the melt pressure is significantly lower, the motor load is lower, and the potential to run at a higher line speed is there. So that's all good. So what that means is that, from a sustainability point of view, we can look at potential energy savings here. And as you're about to see, we're able to introduce some interesting properties too, which would mean that customers can even consider some down gauging. So this particular application I'm going to refer to now is in the machine wraps. So machine wraps range in their stretch ratio, and I'm going to focus on the ones that are around about 200%, okay? And the two graphs that I've got here are a tensile curve and just a radar plot. I'll just get this out of the way. Now down here, a radar plot showing a couple of key attributes. Now, before we have a look at those graphs, let's just have a look at the structures that I'm comparing. The reference material here contains 50% of of the conventional metallocene resin, and we're reducing that now to 30% with the Exceed XP8346. So the balance of the formulation is C4LL, and the Vistamax is our performance propylene elastomer grade that we use as a cling additive. And as you can see, this is designed for cost effective because of the relatively high level of C4, which many producers want to do. And of course, we've even allowed a higher level of C4. But the flip side of this, it also means that if you wanted to down gauge this structure, you could also do that as well, given the attributes we see. So looking at the tensile curve, we say that the natural draw ratio, or NDR, as I have, let me just get the pointer up, as I've listed here, is a point around about there. It's actually the inflection point of the tensile curve. And the importance of that is that beyond that NDR, you start getting strain hardening kicking in, which means that the polymer, then the film becomes a little bit weaker, and it can't stretch very easily without sort of becoming, without breaking, perhaps, if it gets too high. And if you have your NDR, if you stretch below the NDR, then you get premature stretching of the film and you lose holding force. So really the objective is to try to target the NDR on the film that you make. Now here, what we're just trying to show you is that by going to the reference structure, we're not losing out at all on NDR, okay? But we're gaining in terms of tear propagation resistance and still maintaining very good puncture at a much lower dosage, okay? Now we can take that one step further and say, well, okay, what happens if we incorporated some Ziegler-Natta C6 into the structure? And as you can see, in both cases, we've got 50% in there. We've still got the 30% Exceed XP8346. And now we've got a significantly big boost in puncture resistance, as you can see. So again, when you have very big improvements in puncture, it raises the issue, do we really have to make a 15 micron film for this? Can we get even lower in gauge? And of course, this is what we're trying to educate our customers into, the concept of the relationship between the use of performance resins and down gauging. Okay, now another very interesting property of this grade is that you can use this grade in a non-cling layer. And what we found is it actually promotes cling in the opposite layer. At the same time, the unwinding force is lower. And you can see those examples here, where we're using C4LL as the film, as the resin used the non-cling layer. Now, the reason why I've used the C4LL as a reference is because we are typically targeting here hand wraps and machine wraps, which would tend to use those sort of grades, but obviously other grades could be used. Now, the other important significance of looking at C4 as the reference here is that in many cases, metallocene skins are difficult to cut on lines. And so we found that using the Exceed XP8346 in the non-cling layer actually is not so bad on cutting. It's fairly forgiving. And so in combination with its easy processing, the fact that it promotes cling in the non-cling layer, reduces unwinding force, and has terrific puncture resistance, particularly when used as a discrete layer, means that this is a very exciting new grade that the cast stretch customers are now having a good look at. And so far the feedback has been very promising, and obviously we want to see how far we can go with this, but we think this is a really good grade and a bit of a game changer for this particular subsegment of the industry. Okay, now that's really what I wanted to talk to you about, the 8346. Now I'm going to get into the XP7 series, and you can see from the melt index and density here that they're very low in melt index, which already tells you that the melt strength, the bubble stability, and the extrudability is there. But the really interesting thing here is that we've now got the density down to 911, 912, which really now opens up a few more boxes for us with regards to some applications because of the extra mechanical attributes you get by dropping that density, as well as the fact that you're now improving your sealing performance as well. So the first application I want to talk about here is stretch hoods. And I think many people will be familiar with stretch hoods. They do compete against stretch wrap and shrink hoods in the marketplace. Okay, so there is a home for all three at the moment. So for where the stretch hood is a home, the gauges can vary quite a lot, but I think most of them would be in the 100 to 120 micron range. And as you can see from the formulations that I've got listed here in the purple and the pink, the purple one lists a single grade, Exceed XP 7052, which is the 0.5 melt index. So what we're saying here is we could use this grade typically in all layers of a coax line if we wanted to, and obviously we would have to add some anti-block and slip as necessary, okay? But from a resin point of view, it's possible to actually run pure 7052. Now, where extra elastic recovery is needed and better snapback, then the addition of a softer blend partner in the core, such as our Vistamax 612, is recommended. And I would say most people are leaning more towards this pink one. But you can see that we've now really transformed our previous offerings in the marketplace in stretch hood to something that can be used in all layers with the possible addition of a blend partner in the core. Now, if we have a look at the properties, say compared to a reference, in general, the property improvement is significant, certainly in terms of secant modulus, tensiles, holding force, and needle puncture. The MD tear looks a little bit defensive here. And as you can see, the addition of Vistamax in the core layer does improve the tear on the pure solution, which is solution 1. But the needle puncture is particularly good, and the improvement in puncture resistance partly offsets the need to have super outstanding tear. The feedback that we've generally had from the marketplace has been pretty positive when it comes to the complement of properties. And one of the things that we do get fed back is that they find generally that the stretching operation on the stretch hood machine tends to run pretty much trouble-free. And what that really means is that if you're going to encounter sort of really bad tearing and stuff, you know, you'll hear about it then. But generally, it works very well. So there's a nice simplified solution exploiting, again, the melt strength and the toughness of the resin, and the lower density, purchasing some more elastic recovery, and that which can be improved upon, as I said, with a blend partner. The other good thing about it is the haze is also very good, and the nature of the resin is such that it has reasonably good openability as well. So customers, once they get to try it, they actually warm to it fairly well. So you can see that some of the value here would be to replace some of these HEVAs that are in the core layers, and even in some cases some plastomers. Okay. So that's an example of stretch hoods. Now I'll switch briefly over to some primary packaging, because some of you would have seen that low density and thought, boy, that's a good grade I can use in some primary packaging applications. And the particular property that I want to raise here is the flex crack resistance. It really is outstanding. You can see along the x-axis here that the 7 series, these 2 grades here, have particularly low hole formation even after 10,000 cycles on the flex crack test, which is now approaching and perhaps even bettering some of the XP8 series, which is our other very good series for flex crack. Okay, and because of its really good bubble stability as well, and its incredibly high puncture resistance, it now becomes a very interesting resin to use in thermoforming applications. Okay, for thicker films, this particular series of resin does offer very good optical properties. And as you can see from the bottom right-hand corner, the sealing performance is also excellent. You can see here our Exceed 1018 series, which has been a workhorse in the marketplace for us since 1995, in fact. And it's still going strong, but if you really need that lower SIT and an improvement even on the plateau seal strength, then these grades can offer that. So I think if you take into account now the overall improvements in sealing and toughness, it really starts to open up markets, say in liquid packaging and bag-in-box type applications. One of those applications might be flexi tanks, for example, which hold very large quantities of liquids. So you need very good bubble stability for making this, which this resin delivers. You need very, very good toughness because you really don't want those liquids to leak. And again, the flex crack property then comes into play here. So if we compare a couple of XP7 series solutions against a market reference at the same gauge, you can see that on the radar plot, the properties are really quite excellent, and there's obviously a lot of potential to exploit this sort of resin in this application. Moving back to industrial packaging again, low temperature shrink was something that we brought to the marketplace recently, even in a webinar series, and the XP7 series plays a major role in this application. So what we're trying to do now is, can we get the shrink tunnel temperature down really quite low, particularly when we're trying to pack heat sensitive products? And as you can see from the examples we've got here, if you look at the purple line, which is based on the 7 series, with some LD in it. Now the LD would still be needed for speed of shrink, but you can see that it's still going to be very rich in the 7 series, that we can actually get decent shrinkage at 120 degrees. Now, it will be a softer resin, which is why the secant modulus is quite soft, but there is always a trade-off between trying to get down to these very low shrink temperatures and then the modulus of that film structure. So that if you need a slightly higher modulus, then you can incorporate some enable, for example, or a good medium density grade of resin that has shrinking properties. But you notice though that even with the addition of that medium density resin, we now have to drive the shrink tunnel temperature up to 130, which is still very low compared to what people normally run shrink tunnels at, but it's still not as low as the 120, which you can do without the medium density inclusion. Okay, now the other advantage, of course, with things like probiotic drinks, which are often wrapped in POF film, is that this sort of film has almost has a repulsive shrink effect on it. So in other words, it can be used to go around these packs of probiotic drinks, and they're fairly easily released, and you're not getting the sealing issue that you would have to some of the labels. Now, if you were even sort of considering putting shrink film around an HDPE bottle as opposed to a polyester bottle, and you're really worried about low temperatures, then this is another sort of type of structure that you could consider. Okay, so again, now we're exploiting the fact that this resin has good shrinking properties at very low temperatures, and is obviously very good consideration for shrink film. Some of the feedback, for example, that we have had is that people are now looking at this sort of resin as to perhaps reducing their energy costs if they can run their conventional shrink structures at an even lower temperature than running today. Not necessarily at 120 or 130, but just lower than what they're running today. And they're going to try to translate that into potential savings. The last example I wanted to talk about is inclusion bags. And inclusion bags are those sort of bags that are used to wrap rubber bales, for example. And when you process a rubber bale, the packaging actually goes into the processing unit, so it gets sort of melted and dissolved into the bale, okay? And it's usually at the domain of things like HEVA resins and things like that. Well, now that we've got these resins that have got particularly good puncture resistance and low Vicat softening points, you can see that there is potential of these films, of these resins to go into this market. I don't have any data on this at the moment. This is more, I would say, a potential market to look at, but it's definitely an interesting one. And I guess if you had to pick one of these two, you'd probably go for the 7052 first, because it tends to have the lower temperature attributes that you're looking for. Okay, so that's really what I wanted to capture in the XP7 series. It's a very interesting set of resins that can be used in both industrial and primary. Okay, really exploiting the flex crack resistance benefits, the processability, the melt strength that can also be used in thermoforming applications, and of course, low temperature shrink applications. Okay, the last one we'll talk about is design for recyclability with Exxon polymers. Now, we've already had some very good talks already focused on recyclability. We've had a case pushing the BOPE approach, and then more data on the MDO approach. I'm not here to say which one's better than the other, but it's clearly an angle that customers are looking at. And the reason, of course, as everybody has explained before, is that we're trying to replace the nylon OPP, OPA type, the PET, OPP, OPA type of substrates, which are not recyclable with polyethylene, with a polyethylene type substrate. Now, I've also included in this substrate just PE, in other words, unoriented PE. And the reason why that still has to be looked at is that there will be many customers that haven't invested either in MDO lines, or they just don't, or obviously they don't have access to a BOPE line, which are far more expensive, and they're trying to make do with what they can. Now, this is very limiting, because when you have unoriented PE in your substrate, you get a much softer film, which is optically not so good, and you really do struggle with a decent sort of overall laminate. But there will be some cases, some applications where it will be successful. The focus now that I'm going to talk about really is on the MDO part. So we all know that there are a lot of challenges with full PE laminates, and that's been well discussed by our previous talkers. Things like, suboptimal bond strengths. Obviously, the heat sensitivity on the side closest to the sealing bar is particularly difficult to handle now when you're using heat sealing bars. Sometimes the spouts can be difficult to incorporate. Recyclable barrier solutions are always a problem. So I'll talk a little bit about recycle and a little bit about barrier in another slide. This diagram I have on the right is a simplified 5-layer structure for an MDO substrate. And rather than listing the resins, I've listed the attributes that one may try to achieve when they make the substrate. Now, this is obviously the film that they make on the blown film line prior to the MDO, okay? So heat resistance and optics, how do you do that? MDO is very useful there because you can afford to use a higher density type of polyethylene product when you've got MDO and not sacrifice your optics, and also get good stiffness, right? You'll probably still need extra stiffness on some subskin layers, and you still need a degree of toughness in your substrate, but obviously toughness normally means bringing down the stiffness. So again, the MDO compensates that for a large degree. Now, this is, as I said, a very oversimplified diagram. There will be different arrangements that people can use and blend, but these are the key aspects to it. And of course, lastly, you need to have a side to laminate to the PE sealant. Notice in this particular example, I haven't talked anything about including a barrier resin of any type. This is just a straight polyethylene type. So I'll give you an example now of a 5-layer MDO substrate structure where it's been laminated to a 5-layer PE sealant, okay? And what I'm going to do is I'm going to compare that particular structure against a BOPA structure and a BOPET structure laminated to some some competitive sealant structures. Now, you'll notice in the MDO, it's about 25 microns in this case. Obviously, it would start off a lot thicker than that, probably around about the 125, 150 micron mark, okay? The nylon or the BOPA is typically 15 micron in the industry, and polyester is typically 12. So we're competing here against known type of gauges in the marketplace. And if you look at the radar plot over here, you'll notice that even on the bending stiffness with the MDO, we're still able to achieve pretty good performance. It's not quite as good as the polyester. It's not, and the nylon sits in between, but it's pretty darn good. So that's actually a very pleasing result, okay? In terms of the optics, it's also pretty good. And again, if you're running an unoriented PE substrate, then that would be a lot more defensive than that. If we move across to the stiffness factor, this is particularly pleasing because now we've got stiffness pretty much the same as the BOPA solution, but not obviously as good as the BOPET solution. The dart is obviously a very strong attribute of the nylon type of structure, but we are at least as good as the BOPET. So you can see that comparing BOPET versus BOPA, they have their pros and cons as well. And then if we move around a little bit forward, we can around a bit further, we can see now that the puncture and the tensile of our resins is very good, but probably the most pleasing point on this is the one at 12 o'clock, which shows you that despite some of these potential deficiencies over here, for example, the stand-up pouch bag drop performance was still very, very good and rivaling that of the nylon structure. So this is showing you that you can get good success in terms of not only the extrusion, not only the converting into MDO, but also the performance of the final product. So you can get excellent bag drop, great puncture, and you know, it's something that customers are continually looking at. Now, what I haven't covered really is how do we get the recycle in there, and how do we get the barrier? Now, I'm not going to focus really too much on the barrier today. We know customers are already using some barrier resins, and we find it's actually more used in the sealant resins rather than the substrate. There are different types of ways of achieving the barrier, and there's a lot of work being done in that space, which I'm not going to cover. But let me just give you an example on the left where of a fully printed laminated PE solution using ExxonMobil performance resins based on an MDO substrate, and all of this is based on 100% virgin polyethylene. And you can see it looks nice and it's functional. We can also add up to 30% recycle in the overall structure, not just in the sealant, but the overall, okay, and still get a resin and a stand-up pouch that performs very well for its target market. Now, in this particular case, we'd be looking at non-food applications because of the concern of the recycle. And we'd be looking at things probably like fabric conditioners and detergents and things like that, okay? So again, the use of recycle, it will be maximized by using performance resins to bolster the performance of those resins. And of course, the move to 5-7+ layer lines on your extrusion line also means that you're far better positioned to tailor the structures that you want, to keep recycle away from some layers and then to maximize the performance of the metallocene and others. Okay, so on that note, I want to conclude my talk. And so really what I want to get across to all of you today is that both industrial and primary packaging are both important markets. There is a lot of work being done on developing performance resins, not just to address the sustainability market per se, but also to get people to understand that high performance resins allows the potential to use thinner, lighter products. And this is a very important part of addressing the whole sustainability question. So I thank you for your attention. And for those of you that want to make any inquiries afterwards, we'd be happy to take any questions. And there's all our contact details. Thank you very much.
Thank you, Mr. Troy. There was a very interesting presentations from ExxonMobil, and with the detailed slides that to introduce the materials from ExxonMobil and the differences of C4, C6, and also the XP series for 8346 CB and 7 series, the properties and the characteristics of various materials could be the solutions to converters manufacturers in audiences today to avoid and improve in terms of strength and tensile, sealing, and also the product like stretch drums and stretch hoods. If you're interested to know more about the beautiful side of this material, please get in touch with a region sales representative, or can get in touch with Mr. Troy yourself.
Sure.
All right. Anyone that you need an email, you can get it from Mr. Troy or get it with the Secretariat office. Right. Thank you, Mr. Troy.
Thank you very much.
So we'll go ahead with the next one. For the topic, global movement of mono-materials packaging challenges and research trends for PE-based material. Somebody Tong Bai.
Sadika.
Hi.
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 Okay, may I
So,
start from, yeah.
Let me introduce a little bit.
Okay.
We have Miss Kayanu Nachamnan here. She's a researcher with the Thai Polyethylene Co Limited, which is SCG Chemicals. Ms. Kayanu has spent the last 10 years working on a material R&D for LDPE, focusing on extrusions and coating laminations. Before that, she spent 4 years working on a material science R&D for high-density polyethylene HDPE, concentrating on bi-stretching applications and full PE solutions. She also graduated with Masters in Chemical Engineering from Kazakhstan University, correct?
Yes, yes.
I hope I
correct.
pronounced the university correctly. I hope your principal or is not here. I don't know.
Okay,
Right, please.
Thank you. Okay, thank you for your kind introductions. I will share my screen. Okay. Can you see my presentation already?
Yes, for myself, everybody is okay.
Okay, ค่ะ สวัสดีค่ะ Selamate Hale. Good afternoon, everyone. I am Ganyanat from SCG Chemical or Thai Polyethylene from Thailand. First of all, I would like to thank you, MPMA, to invite me for join this conference. And first of all, it's my honor to be here to present you how SCG move on the global trend of the sustainability and circularity and what we have done to serve with this trend. So let's move. For the whole story here, I would like to start with the global issue and what is the global brand owner movement and what is the challenge to change from the multi-layer, multi-materials packaging to the monomaterials packaging, and what is the movement of the global packaging industry. And the important thing for today, I would like to introduce our SCG Green solution to serve with the inner circularity. And finally, how can we make it better together? Okay, let me introduce my company first. The Siam Cement Profit Company is the largest cement company in Thailand and Southeast Asia. The company was founded by King Rama VI around 100 years ago as a national cement supplier. Over years past, our business have the 3 core business. The first one is SCG cement building materials. The second is SCG packaging, and the last one is SCG chemical that we come from. For SCG chemicals, our core business is a polyolefin producer with the global partners such as Dow, Mitsui Chemicals. Our products are we have a variety of the lengths of the product. For example, polyethylene like a HDPE, LDPE, LLDP, and also MDPE. And for the PP resin, we also have the PP block copolymer, PP homopolymer, and also PP random copolymer. And we also have the PVC industry as well. Besides, we also have the 3-scale cracker in Thailand, Indonesia, and new complex in Vietnam. Okay, let's move to our story. Let's start with the global issue. I am totally sure that everyone have faced this problem before, not only for the social media, but also direct experience on that. Yes, we are talking about the plastic pollution or plastic waste. This is a serious problem and mainly impact on our earth in the end. The plastic has been as a killer. So the question is, how can we make it better as we are the resin producer? Okay, let's move to the global movement. One of the solutions is the way on the sustainability and circularity. Leading global brands producer work toward to reduce the plastic consumption. 100% recyclable, reusable, or compatible packaging by 2025 or earlier. And to serve with the trend of the sustainability and circularity, the 4R is implements such as reduce the total packaging use and reduce the packaging waste. The second R is the recyclable, to emphasize the recycling and increase the recyclable up to 100%. The third R is recycle, emphasize the recycled content and incorporate high degree of the recycled content in the packaging. And the last R is the reduce. To reduce the GHG emission, that is the renewable. So let's move. I have some questions to the audience. Do you know that how many % of the plastic consumption have been recycled? The answer is only 9% of the plastic consumption have been recycled, and around 12% of the plastic consumption have been burned up. But the problem is almost 80% of the plastic consumption has accumulated in the landfills or dumped in the national environment. Why? What is that? Why is occurred the problem like that? Refer to the multi-materials packaging. This is just for example. There are several types of the materials in one packaging and it cannot be separated. Another question is why? Why the conventional packaging needs several types of the materials, since they need a lot of function and needs a specific function in one packaging. For example, aluminum, metallized PET, PET for a barrier layer and to extend shelf life of the product. And the other example like a sealability, like a seal layer, for example, LDPE terpolymer. This is just for example. So the question is, what is the challenge? And the challenge is how can we combine these functions into one material that is more preferable for the plastic streaming stream. So let's move to the global packaging industry movement. Many global brand industries have moved on this trend. For example, Hyde have introduced their solutions as the first baby food products to be a truly recycled, making with full PP structure. And Nestle is the first global confectionery brand to switch to the paper packaging. And the second is Unilever. Unilever have launched full PP packaging with metallized OPP in 2020. And the last one is Nescafe have launched full PO with their 3-in-1 coffee sachet drink. And this is just an example. It is also a lot of development ongoing and it not include here. The most important message here is let's get it started now. Every company do their best to achieve the recycling target, even though concrete solution of the barrier material yet. So back to our journey. What SCG have done for the enable circularity trend, we are proudly to present SCG green solutions that can implement into 4R, reduce, recyclable, recycle, and renewable. But for today, I would like to focus only the second R, that is recyclable. And the next question is, what SCG have done for design for recyclability? Before we go to that point, I would like to introduce the development background a little bit. Until now, you can see a lot of effort from the resin producer, machine maker, and also the film converter. Try to develop oriented polyethylene printing layer to replace with the conventional printing layer, for example, PET and nylon. In commercial scale, oriented polyethylene printing layer can give a lot of benefits. For example, barrier property like a moisture barrier to extend shelf life of the product. And the other important thing is the recyclability for environmental protection. However, oriented polyethylene printing layer cannot fulfill all requirements of the conventional printing layer, especially for the film clarity and stiffness. But this gap can be improved by the other technology solutions. For example, processing technology like a biaxial orientation or machine orientation, and also the film formulation in parallel. Okay, for SCG, we have developed the high density polyethylene technology. It stands for Siam Multimodal Excellence or SMX technology. With the uniqueness of the multimodal technology, the materials can be designed to balance with the processing and also the mechanical property in the same way. So the next question is, what will be happen if HDPE material from the SMX technology can be implemented and served for the monomaterials packaging? In fact, at SCG, we are not the first one trying to use the PE in monomaterials packaging. The general BOPE have been used and commercial into the market for a few years. However, because of their too low dimension stability, the laminator needs to reduce the production line and also the production rate, and which tend from the bad seal appearance, and it can lead to a narrow operating window of the packaging speed. So with this problem, this why SCG BOPE developed from the SMX technology can solve this problem. So the next question is, how do SCG BOPE and MDO film perform? So let's see how it's different. To compare with the conventional printing layer, in this case, I would like to compare with the PET. And you can see here, SCG BOPE. And if not only for the recycling ability, but also the dark dot property. And SCG BOPE can show the higher 40% dark dot comparing to the conventional printing layer and general BOPE and MDO solution. However, SCG BOPE cannot fulfill the all property of the PET, especially for the film stiffness, as you can see in the silicon modulus. And the other benefits from SCG BOPE is the dimension stability. And you can see we can give the lower dimension stability or lower thermal shrinkage comparing to the general BOPE and MDO solution significantly. So what about the performance on the lamination? Comparing to the monomaterial full PE to the multi-material packaging containing with the PET, it's very clear that some property could be better or equivalent, but for some property could not be the same. It can be solved by the structure design to support the monomaterials packaging. The SCG BOPE can provide the high heat resistance and also the lower thermal shrinkage. And also you can see here, we can give the higher dark dot comparing to the conventional PET printing layer allowed 2 times. And as SCG and as BOP is the early stage of the development, SCG is entering into this area actively and try to collaborate with a global machine maker and also the film converter, trying to develop BOPE into the market. And for SCG, we don't have only the HDPE resin served for MDO and BOPE solutions, but we also have the PP resin that can serve for general BOPP and also the high heat resistant BOPP as well. And we also have the new developments on SCG barrier coated film that can apply for both full PE and full PP solutions. And you can see from the table, we can give the broader length of the barrier property from medium barrier to a very high barrier. So let's see what is our approach for full PE solution. Let me show some solutions. The first one is full PE packaging with the medium barrier that can use for the personal home care applications. In this application, normally nylon used as a printing layer. So we replace nylon with our BOPE and also SCG coating layer that finally you can see here, we can give better barrier property in terms of OTR and the BUVTR better than the traditional one, and plus the benefit of the recycling ability as well. So let's move to the second development. Another example is the full PE packaging with the high barrier that can use for the personal home care products, dry food, and chilled and frozen food applications. Normally, the co-extrusion LLDPE with EVOH was used as a sealing layer, but however, this approach limits on the packaging structure design from customer. For our solutions, we have developed the MDOPE with SCG coating layer and apply in the printing layer that finally our approach can achieve the same barrier property comparing to the traditional barrier solution EVOH. From the whole story here, SCG, we could not go alone. SCG also open to an idea from everyone and from customer to convert into the prototype together. We could provide you our capability on the material design, processing technology and guideline, and also the film formulation with available application development center in both Thailand and Norway. And we still look forward to the new collaborations around the world. For more information and for future collaborations, please contact our team, SCG Chemical team for monomaterials packaging as shown in this slide. And finally, we can do it better together. Thank you. ขอบคุณค่ะ
ขอบคุณครับ Thank you so much for the interesting topic that you just brought towards the audience here today, and you have presented the SCG roadmap with your understanding of LDP and HDP as well. Very much thank you. And well, to all our attendees and the audiences, if you have any questions about SCG, please drop Ms. Kalnud an email, and you can always get in touch with her. Or if you have any questions, you can always get in touch with the secretariat to get in touch with Ms. Kalnud. Right. So, Chan.
Yes. Thank you, Bacon. Ladies and gentlemen, before we start the Q&A session, we'd like you to do a quick poll to access the webinar. You have attended the webinar before. This poll consists of 8 questions. So please start answering now. You have 2 minutes.
Oh, Chan, can I just say hello to the speakers while the participants fill up the poll?
Yeah, sure, Mr. Eddie Fong.
Okay, hi. Good afternoon. I'm Eddie Fong here. Oops, what happened to my screen? There we are. Thank you for all of you and Bacon for taking the time out to chair or be moderator for the session, and all the speakers for taking the time out to speak to our participants. I think I've learned a lot about BOPE, BOPAT, BOPER, and BOPA. I never knew these things existed, but all these abbreviations. So quite interesting to see how the industry has really taken so much initiative to make it single layer, flexible packaging, rather recyclable and so on. So once again, thank you so much. It's been very informative. I think it was a very good response too. We have a maximum of about 185 people today, and I think now we still got 149. Usually halfway through the seminars, we usually lose about 40% of them. But today, I think only lost less than 20%, which is a very good indication that it's informative, interesting, and relevant to our members. Not only our members, I think we have a lot of guests that locked in from even overseas, from Thailand also, because and also ASEAN countries, other ASEAN. So thanks again. I'll say goodbye here and leave you with the questions and answers. Thank you.
Okay, I would just like to also add on to here for the participants. The reason why we are looking, while we have the poll, is for us to have a better understanding about what you want and what you need, so that we can improve on the next sessions. So for those who are still contemplating whether or not to fill up the poll, please do that. And while you're filling up the poll, I would just like to add on to what Eddie has stated, is that yes, most certainly a big thank you to the sponsors as well as all the speakers, and also to Beacon for being the moderator for this session. The session is extremely important for us because one of the key things that has been the mainstay of this event today is about the fact that what the industry has been doing and has been continuing to do and to pursue is how we can achieve a higher level of recycling for the purpose of achieving circularity. Now, the plastic industry is a wonderful industry in the sense that it has provided so much solutions to packaging and to so many things that the world needs for the ever-growing population. But yet, at the same time, we have to accept the fact that plastic has its issues insofar as environmental issues are concerned. So there is a lot of pressure now on the industry. For those who have been keeping in the picture, you will know that UNIA 5 is coming on in February of 2022. The Nordic countries have been pushing for certain proposals where they might want to implement a rule, a written rule, to restrict the production of polymer at the upstream level, which would, of course, impact the industry. So it's important for the industry to be able to have a narrative and to be able to demonstrate that the industry is serious and able to work towards circularity. So today we have seen and heard from many speakers, both from the upstream polymer suppliers as well as the machine suppliers, how they have been working together to provide a solution to converters, so that converters can in turn provide a solution to brand owners, and brand owners can make a product that goes into the market to achieve a certain level of circularity. So for the great work you guys have been doing in your industry and for the good presentation, MPMA would really like to thank all of you. And for Eddie, while you may be new to BOPA, BioPad, and all this, it's something that is familiar to me, even though I've left the industry years ago. And I'm glad to see in today's speakers, two of the speakers are at least known to me. So Troy, a big thank you to you. And Daniel, it's been quite a while since I last met all of you guys, but thanks a lot. You guys have been great. So over to you, Chan.
Thanks, Kokun.
Yeah, thank you, Dato Lim, and thank you all the participants for answering the poll. I now pass back the mic to Mr. Bacon Chen to start the Q&A session.
Hi again. Thank you, Mr. Eddie Fung. Thank you, Dato, for everything. Let's see. Here we go with the most interesting part here, that we have Q&A. That let's go with the first questions. And okay, does the MDOPE bag have vacuum bag? I believe that this question is from Nguyen to Daniel and Jason from Dow.
Okay, I can take this question. Okay, I believe the questions is referring to one of my slides, which I do a comparison on drop test comparison, comparing MDO laminated with PE lamination film against the TFBOPE laminated with lamination film. And of course, this comparison is not a vacuum bag. It's just a normal packaging. So, but it doesn't stop there. But if the customer or Mr. Nguyen, if you wish to consider looking into vacuum bags, I think I have also shared with all of you on the recyclable of the, if let's say, for example, for bearing barrier kind of stand-up pouches, where you can actually use the TFBOPE as a printed layer. And then the lamination layer can be PE extruded, co-extruded with EVO or PA, with, of course, with the retained compatibilizer to ensure it is compatible when during recycle. Okay, I hope I answer your question. Thank you.
Oh, okay. I forgot to unmute myself. Wait, let's see. We have the second questions from, okay, any data on costs or energy saving for XP7 series? This question I believe to target to Mr. Troy. Mr. Troy from ExxonMobil.
So I think that's referring to my comment about running the shrink tunnels a little bit lower temperature for shrink film, I gather. I don't have any data on that. I think it's a comment that we had from more than one listener at our webinar, at their interest in pursuing whether they could get energy savings from XP7 for this application, simply because in some countries, as you know, energy is very expensive. So I don't have any data on that. I don't know if anyone has actually gone ahead and done that yet, or if it's work in process. So that's as good an answer as I really can give you on that one at the moment. But you know, one would think that if you could run at lower temperatures, considerably lower temperatures, that there is probably some link to energy savings.
Right. So, Mr. Troy, there's another questions for addressed to ExxonMobil as well. That is like, is Exit XP7 available in Malaysia now?
Indeed, it is.
It is.
We're waiting. We're waiting for the orders, Mr. Bacon.
Oh, wait. Oh, yeah. Waiting for the orders. Right. So to all the attendees and all the audiences over here, so you now you know that if you need any Exit XP7, right, Mr. Troy is actually waiting for the purchase order and for the sales to come in. And yeah, I don't have to go through me. And please go to Mr. Troy. Mr. Troy, could you please tell everybody your email address again? I'm sure that.
Well, at the end of the presentation, actually, there are all the contact links. So you could probably just go to that last page. Yeah. All
right. Sure. Okay. So XP7 is available in Malaysia. Right. Okay. I have a few more questions. How many % of non-recyclable multi-material packaging in the global market that has already been replaced with recyclable mono-material packaging? This is a question to address to all the speakers over here. Anyone could pick up one of it? How many % of non-recyclable multi-material packaging in the global market that has already been replaced with recyclable mono-material packaging?
I think we can have a discussion on that, but I personally, I do not have any data on that is showing that. Maybe Lucas has some information as well, but I guess it would be more a gut feeling from my side, maybe a gut feeling from Lucas as well.
Yeah, thank you, Marcel. I think I just shared a link on the Ellen MacArthur Foundation because they have quite a nice summarized report on the annual progress of each brand owner. And I think from that you can deduce what's the progress towards each pledge. I don't have the percentage per se of all the global, say, tonnage. What is the percentage which is now fully recyclable? So I'm also with Marcel there.
Right. So what many brand owners are actually having these concerns, right? They pledged to have 100% recyclable packaging by 2025, 2025 or 2030, right? Are we on track to achieve these commitments?
It's hard to say. It's hard to say because each brand owner, as I said, that report sort of gives a 1-year lag of the current progress. And if you look at, say, really big brand owners like Nestle, for example, just to name one, they're around 65%, between 61 and 65% on the way to achieving their target. But the progress hasn't really improved that much, say in the last, say, a couple of years. And it might do so with more investment towards monomaterials from converters as well, from others. And there's a bit of a chicken and egg situation, or horse and cart situation, quite similar to the EV sector as well. Electric vehicle sector is quite similar like this, where the investment in this has to reach critical mass in order to create a lot of recyclable materials. So there are some who are doing innovations, and I applaud them for diving in, because there is some risk. But I would say this, that they're doing so with the pledges as their guarantee effectively. So and there is some effort there, definitely.
Right.
I just want to add on one point here. The pledges are to achieve certain level of recyclability in terms of their requirements. And the requirements is a function of what they have set. For instance, what they have said to say that I want to have a certain level of WVTR or OTR. Is there any sense that there could be a possibility that when you start to hit a certain limit, would they back off and say that, okay, I'm prepared to accept a shorter shelf life or something of the sort?
Honestly speaking, I'm sure most brand owners don't want to make that compromise. There is some talk, depending who you speak to, and I won't name names, what they're going to compromise on, whether it's paying a little bit more, because right now there aren't that many, there's a lot of demand for monomaterials, but there isn't that much supply of MDOP, for example, in the Grace market. I get a lot of questions, and I know Marcel's selling a lot of lines on MDOPE, but I get a lot of questions. What are the suppliers of MDOPE from quite a lot of converters? And the brand owner is also asking, when is it going to be available in my country? For example, for specific brand owners of that particular country. And so, as I say, it's a bit of a chicken and egg situation. It's starting to come. You will start to see more and more innovation coming. And I think between 2022 and 2025, certainly for food packaging, will be a huge push in that direction. I believe some will be late, honestly speaking. They will miss their pledge targets from what I can see today. But this is what I can say.
Yeah, to add, I really agree to the statement of the critical mass. There are many first movers investing in this MDO technology as well in BO technology, and taking some risk to be the first movers and to be ready. And I think that once this critical mass is reached, it will really change super quickly, like exponential growth. Yeah, that just within a few months, the available amount of such films will double easily, because what I see just from our perspective, many lines have been sold. We have long lead times. Yeah, we are unluckily, for some other customers, but this shows us that in the next 12-18 months, many lines will go online. And especially I know cases where the film is ready on the market, but the big OEMs, they say, no, I can't rely just on one supplier. Even if he could supply the amount I need of this film, I can't rely just on a single source. So I wait until I get at least a dual source strategy for this type of film. So, and everybody is like a little bit waiting, but I think it will change quickly now in the next 1 or 2 years. Do we have 100% at 2025? I doubt it. 100%. The last 5 to 10% are always the hardest to achieve, but I think we will be somewhere in 90. Just my gut feeling again.
All right, thank you, Marcel. Thank you, Lucas, for answering the questions. And because we are running a little bit late and it's 4:45, so we have some questions that are not able to be answered. We will try to get it to the speakers, and I'll try to reply to you by the email. Is that okay, everybody? So, right, I'll have to say thank you again, and we will go for a photo session. Can we all turn on the video, the camera, so that I can see all of you, because all of you have been seeing my face for the past 2 hours. Yeah, laugh a little bit, yes. Can we have Mandy, Suming, Malati, Crystal, and Wendy?
The Secretariat has worked really, really hard in setting up all these events. So I think they should come on the come into the photo as well. So the rest of you, can you just put on your video?
Hello, hi.
Yeah, Malati, Mandy, Wendy.
Andy.
So that at least the audience can see you guys.
Dato, I couldn't sleep last night because of this event.
Wow.
No worries, just
That's good. That's good. That means you're excited.
be relaxed, be relaxed. It's just
No,
one of
just
the
kidding.
days, not a problem.
Right. So someone's gonna take the picture?
Who is it?
Yeah, we're taking the picture.
You've taken the picture.
Yeah, you should
No,
give
we're
the warning
taking
of
the
1, 2, 3, say cheese.
Yeah,
Okay, do it again.
Okay, we do it again.
Okay.
Okay, 1, 2, 3. One
Okay.
more. 1, 2, 3.
Okay.
Okay, done.
Okay,
Thank you.
right.
Thank you, Bacon.
Thank
you,
you.
our
Thank you, Chan.
speakers. Thank you,
Very
Tato
much.
Lim.
Thank you,
Thank you,
everyone.
everyone.
Stay safe.
Everybody.
Most important thing, stay
Thank you.
safe.
Yeah,
Bye.
to all the speakers,
Bye.
we get the pictures for free, and whoever wants the picture, we can give it an offer price. Order. Right, Lucas, right, myself. You buy a machine, you get the picture.
Thank you.
Okay,
Okay,
everyone.
Thank you,
Have a
Daniel.
good
Thank you,
evening.
Lucas. Okay, thank you.
Bye.
Bye-bye.
Take care.
Bye now.
Stay
Goodbye.
safe.